Hello, good morning all. How are you? My name is Achmi. Today we are going to discuss about a very curious and interesting fact. Can you guess what we are going to learn from this picture? Yes, periodic table. We are going to learn about periodic table. So, we all know that periodic table is the systematic arrangement of elements. So, when we think of periodic table, there is a list of names of scientists that comes to our mind, right? Because there were a lot of scientists who tried to classify elements in a systematic order. Though many have tried to classify the elements, they have faced with certain limitations. We have seen the classification by Mendeleev. Today we are going to discuss about modern periodic table. After Mendeleev's periodic table suffered some limitations, Henry Moseley introduced a modern periodic law which states that the properties of elements, that means the physical and chemical properties of elements, depends on their atomic number, not atomic mass. So he arranged elements in the increasing order of their atomic number. This helped to overcome these limitations faced by Mendeleev, because he believed that the properties of elements is the periodic function of their atomic mass. That's why he couldn't give a proper place to isotopes. In this law, he stated that the properties of elements, that means both the physical and chemical properties of an element, depend on the atomic number of that element, not atomic mass but atomic number. And he classified elements in the increasing order of their atomic number. And this classification is known as modern periodic table. So we can see in modern periodic table, elements are classified into 7 rows called periods and 18 vertical columns called groups. The elements in same group exhibit similarities in character, and due to this the groups are also categorized into families. That means among these 18 groups, they are categorized into families because they exhibit same character. In modern periodic table, 118 elements are classified in the increasing order of atomic number. Let's take a look at those.
1, 2. I read that nuns have the most say about what heaven is. Then don't you think their doubles must live in hell? I've had this vision of nuns in the attic. It's a little bit like sleep paralysis. It's cringy and campy, there's no question about it. But it's more than just superstition. I think there might be something in my cognition, but I'll just wait till I'm fine.
As I have said before, the elements in same group shows same characteristics, so they are classified into families. The families in periodic table are: group 1 is known as alkali metals, group 2 is known as alkaline earth metals, group 3 to 12 is known as transition elements, group 13 is known as boron family, group 14 is known as carbon family, group 15 is known as nitrogen family, group 16 is oxygen family, group 17 is halogen family, and group 18 is noble gases. So I have a question. Why do elements in same group show same characteristics? So let's examine it with the elements of group first. Here the electronic configuration of elements of group first are given. Observing this, we can see the number of outer electrons of all elements are same, which is 1. So as one can see, the last number of electrons in the outer shell of elements group 1 are same. This is same of all the elements in same group. That means the elements show similarities in character because they have same number of electrons in the outer shells. Elements of group 1 to 13 to 18 are known as main group elements. These include metals, nonmetals, and metalloids. In this, group 1 is alkali metals, 2 is alkaline earth metals, 13 is boron family, 14 is carbon family, 15 is nitrogen family, and 16 is oxygen family, and 17 is halogen. And 18 are, as we all know, noble gases. Also, they include metalloids, which shows both the characteristics of metals and nonmetals. So the metalloids we can find in the periodic table are boron, silicon, germanium, arsenium, antimony, tellurium, and polonium. The next is transition elements. These elements include elements of group 3 up to group 12. They show a transition between metals to non-metals. That's why they are called transition elements, and they have very peculiar characteristics. The transition elements not only show similarities in groups but also show similarities in periods also, and they also forms colored compounds. There are certain examples of colored compounds formed by transition elements. Nickel sulfate, which shows a bluish greenish color, copper sulfate, which shows blue color, calcium carbonate, which shows no color or white color, potassium permanganate of violet color, cobalt nitrate of red color, and potassium dichromate of, as we can see, orange color. Then there is inert transition elements. You should have noticed a table is separately given in the periodic table, which is not attached to the main block. Why? Because those elements are known as inert transition elements. That means in the 6th period, lanthanum and the 14 elements following it have been arranged separately at the bottom of the periodic table. The elements from lanthanum, which atomic number is 57, to lutetium, which atomic number is 71, are known as the lanthanoids. And in the 7th period, actinium and the 14 elements following it have been given a separate position below the lanthanoids. The elements from actinium, which have the atomic number 89, to lawrencium, which have the atomic number 103, are called actinoids. These lanthanoids and actinoids are known as inert transition elements. Lanthanoids are also known as rare earths. Actinides, coming after uranium, are man-made elements. So, to sum up, there were many scientists who attempt to classify the elements in a systematic order, and Mendeleev's came close to that arrangement, but there were certain limitations for Mendeleev's periodic table. Even though there were only 63 elements discovered in his time, and he classified elements in the increasing number of their atomic mass, because he believed that the chemical and physical properties of an element depend on the atomic mass, not atomic number. But there was irregularities in the so-called arrangement of increasing order of atomic number, so he didn't succeed either. Then there came Henry Moseley with his modern periodic law, which state that the properties of elements, that both the physical and chemical properties of elements, depends on their atomic number, and he classified elements in the increasing order of their atomic number in a way that The elements came in same group showed same similarities in physical and chemical characteristics. This is because the number of outer electrons of the elements of the same groups are same. And the modern periodic table consists of 7 periods and 18 groups. So, in the periodic table, there are families such as alkali metals, alkaline earth metals, and 3 to 12 is known as transition elements. 13 is known as boron family, 14 is known as carbon family, 15 is known as nitrogen family, 16 is known as oxygen family, 17 is known as halogens, and 18 is known as normal gases. And there are main group elements which include group 1 to 13 to 18 and transition elements which include group 3 to 12 and inner transition elements which are lanthanoids and actinoids which are separately given below the main body of periodic table which are in 7 period lanthanoids and 8 periods as actinoids, and the lanthanoids are known as rare earth elements. So this is all about the modern periodic table. Thank you for watching. I hope the idea is clear to all, and if you have any doubts, don't hesitate to comment in the comment box. Thank you.